Up next is a great panel discussion on open source Trino, formerly known as Presto, with the co-creators themselves, moderated by Paco Nathan from Gradient Flow. The focus of this panel is how Trino and SQL can help accelerate data science. I'll turn it over to Paco now.
Hi, my name is Paco Nathan, and welcome to our panel here today. I'm really excited about this. Our topic is Trino, SQL, and accelerating data science. And on our panel here today, we've got Martin Traverso, Dain Sundstrom, and David Phillips. Very glad to see you all. Look forward to our discussion here. I want to just describe a little bit. We'll be going through a few different talking points here about what's going on in the industry in general, some themes that we're seeing in the industry, and the importance in terms of data engineering practices, data science practices, and really how do those meet and align very effectively. And then, we're bringing this back to tie into Trino, and toward the end, also looking toward what's on the horizon for roadmap and some of the future. So first up, I'd like to hand over to Martin.
Hi, I'm Martin. I'm here with Dain and David. Together, we are three of the original creators of Presto. We started working on it back in 2012 when we were at Facebook, and we spent about 6.5 years working on it. So Presto is now known as Trino, so we'll be referring to it that way throughout the talk. And so we spent all those years working on Trino, building the community, building it as an open source project. It's become a global project with contributors and users all over the world. And then over the past year and a half or so, we joined Starburst, and we are CTOs.
I'm Dain. I'm also, as Martin mentioned, one of the founders and a CTO at Starburst.
Hi, I'm David. Same thing.
Thank you, Martin, Dain, David. Thank you very much. I've really enjoyed talking with you all over the years and seeing how this has grown. And in particular, there is something happening right now in industry that I wanted to dig into a bit to start off our conversation. We've seen surveys, coming out of MIT Sloan, coming out of McKinsey and others. Also, just my colleague Ben Lorca and I have been doing industry surveys. One of the main pain points that we're encountering in enterprise is that a lot of companies are struggling with tech debt in terms of their data infrastructure. They're struggling with just, the age-old phenomena of having a lot of silos in enterprise where, people have their own fiefdoms and they don't talk enough with each other. And now they're being confronted with a lot more pressures regarding data. And, this whole constellation of issues that come in about compliance and privacy and security, but also just the competitiveness of you really need to leverage the data to be out there. And then on top of that, we have 2020 and all the other pressures that come along. So, that there's this one pain point that we're seeing where this lack of being able to work across enterprise with effective data engineering, effective data infrastructure, it's becoming a real showstopper, in a lot of corners. So I wanted to dig into a bit about that with you, and what do you see as some of the issues there, some of the challenges? We'll kind of unpack this a bit. I'll start off, Dain. Trying to address this problem in enterprise. How do you move forward on it?
Yeah. So data silos I don't even know if we could even call them a problem. They're a reality of running a business. And I think it has been for, 20, 30 years now. Like you naturally end up with these in any business of size. You go through acquisitions, you bring in other companies, they have different tech. But it happens even in companies where it's like, oh, I have my marketing group and they're going to build a data set that's very marketing focused, at pulling in data from all their different marketing tools. And then I might have a customer service that's, building data sets around like how customers are interacting through phone calls or whatever. And they end up being different data sets. What's interesting is that even within a single org, a lot of times you might end up with silos in a single org simply because of the technology constraints of the different kinds of data. Like you might end up with a super fast store for doing transactional data that's really custom to a problem, like something that hooks directly into the customer service call system. And it's a very customized store. And you might have a traditional SQL database there on the side that are stitched together in an app, but they're actually just different data stores. So I think this has been around for a really long time, and there have been some solutions since probably the 80s, people have, the answer has been like, well, let's take all the data that's interesting and pull it together and do a new store. And that works well to a certain point, but the problem is that it's infeasible to get all the data in, and you have to go through it's too expensive, it's a lot of work, every data set. So it's like, oh, I want to add a new data set, it takes a week. I think every data scientist knows this story. You're like, oh, I need the marketing data, let's get that imported. And assuming marketing wants to let you do it, if they don't, then that's going to take you a quarter just to go through those conversations. Once you actually decide you're going to do it, what data, how does it work, how do we, those decisions are going to take, months. And then every day someone wakes up and they're like, did the import work or not? So it's a really hard problem. And then at the end of the day, you buy another company and they have their own store. And now how do you merge those two together? And it just gets worse and worse. So the solution that we came up with was, let's stop trying to move all this data around. Let's just figure out how to query where it is. Let's break that problem of I have to get all the data to a single store ahead of time. And that, of course, introduces a new set of problems, which is like, great, now I have all these different stores. I can query them all together. Do I want to? Is that efficient? They might have, different data sets, which are different ways of describing the same data, which is common in the other system. It moves the problem down the road.
So the metadata or data standards of one team may be vastly different than another team next door.
Yeah, you bought a company and they refer to products using different terminology, for example. And these are part of the process. Every data scientist I talk to is just obviously, none of the data agree with each other. That's a huge portion of our job, is figuring out what does the data even mean.
Yeah, exactly. That's the anecdote or aphorism, I guess, actually at this point, is that in data science teams, you spend 80% of your time just cleaning up data, and it's mostly for this exact reason. And when you look at a larger company, how much annual spend they have on data science teams, that's an interesting number. Well, Dana, I'm hearing a lot more discussion about data catalogs. I think that in light of GDPR, this is kind of coming more into industry practice. But how does that fit into this picture as far as making queries across a number of different systems?
So data cataloging is it's a pretty big space. There are a number of different kinds of them. A lot of the data catalogs they're about normalizing the way that you look at data, but they don't actually get you to a query engine. And if they do, the technology is typically, and I'm talking very vague here, is typically focused on the data catalog, and the query engine side isn't great. We focused on, we're going to connect to all the different data stores and try and expose them real directly and be able to efficiently query all of them. Most of the ones that I'm familiar with don't actually get you to a big, efficient distributed querying system. The other problem is that data catalogs, they're typically, they need to be, it's not really a problem, they're typically a form of the global solution where you pull all your data together and you normalize it. You have to have a big committee to work through all these different orgs and get everyone to agree to how they're going to normalize their data, and then everyone actually has to do it, but then they don't actually normalize all of it. They only normalize the data sets they think are the most important, which may not be the ones that are the most useful to data scientists. So it goes back to a pick and choose solution, as opposed to like, you can just get to everything.
Okay. There's also I got another point about that. It's also a technical challenge with having a global catalog, because you have all these disparate systems. You may have a MySQL database, a Postgres database, you have Hive in the middle, and each of those systems manages their own catalogs of tables and schemas in its own way. They have their own constraints, their own capabilities. Like if you want to centralize all that in one place, you have to deal with, well, how do you match up all the concepts across all those systems? How do you keep all that data in sync across all those systems? Like you may not be able to do it in a consistent way. So you end up with problems where you may have a view of a table at some point in time, and that changes, and you are not able to realize that changed until you have some reconciliation process. So it introduces another dimension to the technical challenge that you have to deal with.
Okay, so following up on that, Martino, I wanted to ask you a bit if we could drill into this part that, when we think about like a traditional data science workflow, you've got different data sources, you've got a lot of data prep work that you do, but, in a more of a traditional sense, you're thinking about relying a lot on ETL, and there are these overhead costs. Are there ways around that to try to mitigate some of those costs?
Yeah, so one of the things that happens in traditional data warehouses, or even with data lakes, where people have this idea of, we're going to put all the data in one place. It requires, like, if you want to be able to analyze as a data scientist, data analyst, you want to be able to analyze what's there, or run experiments, do interactive ad hoc analysis, or try to explore the data. You end up first having to get the data in there, right? You have to get your data from your operational data stores into your data warehouse or into the data lake. That requires coordinating with other teams, with other people. And that introduces a lot of lag and latency in that process. So if you just want to explore your data, and at a time when you may not even know what questions you're trying to ask, you're just trying to see what does the data tell me? What does the data say? You don't want to have to wait weeks and weeks before you can even start asking the question. So with Trino and the ability for Trino to tap into the data sources and the data where the data lives, it allows you to start exploring those questions and start figuring out, building a mental model of what the data tells you, how things relate to each other. You can formulate questions, get answers quickly, like without having to consider much about optimizing your process for how you're going to ask those questions once you settle on them. And then at some point, you're going to have those questions or processes solidified. You may want to produce reports. You may want to produce result sets that feed into other processes later on, or further analysis. And you can at that point start figuring out, okay, now that I know the questions I have, I can build a recurring process that will generate a report and put that data somewhere else, and so on. Or it allows you to, having this ability to tap into the data sources where data lives, allows you to maybe look at the data. If you realize, well, this is not very efficient because data source is not very efficient, I can take a snapshot of the data right now as it exists right now, do some analysis, then throw it away and keep going, which is not something that you can do in traditional data warehouses without these complex ETL processes.
Right. I mean, that's interesting. So, adapting to process then, just to kind of summarize some of what you're saying there, what really strikes me is there's this kind of human frailty, if you will, that when we're working with complex technology, we always revert back to waterfall and just supposing that we have the questions in advance. But from what you're saying there, I mean, we have to think in more agile terms where we iterate and we develop, questions as we're working through. I'll make a note here that there's some really great articles at HBR by Eric Colson out of Stitch Fix talking about, one of the main characteristics that you really want to build in a data science team is curiosity. And this idea of, like, you don't have to have all the questions up front. You have to dig through them.
I see this technology as being like really empowering. I heard this story about a massive manufacturer in the US during the very early days of COVID. And like, you know, the CEO's like, you know, I know we have a bunch of companies that make masks. So this is a huge conglomerate. They apparently have like 35 companies that make face masks that, you know, okay, great. How many do we have? What's our capacity to make masks? And literally they couldn't actually find this question out. And you have to go to like every single company and like, first question is like, what do you mean by a mask? What technically qualifies as a mask? What product numbers align as masks? Like, you know, what do we have in warehouses? How do the different warehousing companies refer to these different products? And it's unbelievably complicated. And they couldn't even really begin to approach like a global view of this message, which in the time period they really would have been really useful. And I can imagine this sort of thing. Like, I mean, yes, this is a huge public health crisis. It's like a really kind of sad story, but like a normal everyday kind of business problem would run into these same sort of things. And so like, it's not only empowering to like the individuals, I think it's really empowering to the company to be like, if push came to shove, like we could get a team of data scientists who could actually start to like bang on one of these really hard problems.
Well, I mean, that's just heartbreaking when we think in retrospect, like what could have been done differently and all. And I mean, we can plan a lot in terms of engineering, but we can't plan for crisis. I mean, we can't plan out crisis by its nature. We don't know when the next crisis is going to hit. And the world is being more and more powered and dependent on data, and we know that more crises will happen. Are there some? I mean, can we dig into some more technical details of you know what this means with Trino? What's some of the technology involved here as far as working across different data management systems?
Well, there are there are a number of pieces to the puzzle here. So Trino, at its core, it's extensible. So you can, it has an API for building connectors to data sources. Connectors have to provide metadata and a way to fetch the data for a given table in an external data source. But it also provides advanced features, like, for example, the ability to interact with the optimizer to first of all, to provide statistics about the data that the optimizer can use to figure out the best way of ordering joins to make the execution the most efficient possible execution, minimize memory utilization, and so on. But there are other aspects, like, for example, being able to push down certain parts of the computation into the data source. Like, for example, if you're talking about a query over a Hive data set, the connector for Hive understands the data model and the layout of data in Hive, and it can use information about the shape of the query to prune out partitions that shouldn't be considered as part of the query. So that can improve performance dramatically. It can also take advantage of filters over data when reading data from, say, from Parquet files or ORC files that have some information inside the file that can be used to prune sections of the data or skip sections of the data and avoid the cost of reading, decoding, and so on. And then when you're talking to, when Trino's talking to more sophisticated data sources, like, for example, you can consider a SQL database as a smart data source, smart storage engine or something. Trino can take advantage of some of the more advanced capabilities by pushing down computation into those data sources. For example, if you're doing aggregations, instead of pulling all the data into Trino and then letting Trino do the aggregation, Trino can push down some of the computation into the engine, into the SQL database, and let it use its own algorithms, its own data structure, and optimize indexes, etc., to compute that in the most efficient way, and then provide the resulting intermediate data to Trino, which then can use it for the remainder of the query. So it's kind of a complex dance between the engine and the connectors, and but you can think of it as a connector participates in the optimization process, and And some operations can be done either in Trino or in the connector, depending on the capabilities of each of the systems.
Is some of that available, exposed, or manipulable from the application layer? Like, can an application layer do any sort of hinting into Trino about some of the pushdown effects?
There are some things that an application can do. There are some behaviors of the engine that can be controlled via session properties that are, or either configuration on the Trino server or session properties. But I would say, and philosophically, we try to make Trino as transparent as possible to users. So we want users to not have to think about that. Like, it's possible that at some point in time, we may have toggles for those behaviors because the engine is not smart enough to figure out what the best way of doing it. So we have to let the user decide. But over the long term, we want the engine to become smarter and be able to take advantage of, or be able to make those decisions for the user.
Yeah, there's really a spectrum where if you can push it down, it can be a lot faster. But if you can't push it down, Trino can just still do like a raw scan and get the data and answer your query anyway. And a lot of like performance is really limited to what is available in the data source. So if you've got to do a full table scan because there's no way to do any filtering on the data source side, then you're going to do a full table scan, and that's going to be your limiting factor. And for like exploration, often, like Dain said, you're just limited to that. But people also sometimes, when they're going to be running repeated queries, or they're going to be doing reports, or they're building a kind of a custom application, they'll lay out their data physically to make those operations faster. But there's a high cost to that because you've got to know what you're doing, you've got to understand your access patterns, and then when you want to go and add a feature to the application that doesn't match exactly how you've laid out the data, now it's going to be a lot slower. Sometimes you have to do both. Like, we worked on a custom application that had tables with trillions of rows that had to do joins with billions of rows. So we had to be really fast at doing brute force, but we also had to physically optimize it because if we were scanning all the data, it never would have worked.
We spent a lot of time, like, we have a bunch of philosophies as we're doing our development, and one of the big ones I think applies here is simple things should be simple, complex things should be possible. So like, you're just trying to explore some data, like, I'm just going to type some queries in, like, you figure it out. It just should generally just work. If I want to build a system that's going to, join a trillion rows with a billion rows, and I want to run hundreds of queries a minute, like, yeah, it's possible. It's definitely possible in Trino. It's not easy. Like, we did a lot of custom work to pull that off, including a custom storage engine. And it's possible, though. And we try and hit both of those.
I'm curious about Iceberg. This is something I've only really just started learning about recently, but I think out of what I see at Apache, one of the more interesting projects. And that's probably something I imagine other people haven't heard as much of yet. Can you describe a bit more about what's going on there?
A brief overview of like what Iceberg solves. You kind of have to understand how, like, what Hive is and how it came to be. So Hive was started off with a pretty simple data model, basically like, I've got a bunch of text files on a distributed file system, and then I want to be able to run queries over it. So, okay, I need to know, like, what are the columns in my text file? And then they later added partitioning, which is like, oh, I put my text files in, different directories, and I organize them by date. And then, okay, that's your partitioning. And so Hive is like very simple, just value-based partitioning, where each unique value is like a different directory or partition. The problem there is that all this data about your tables is stored in the Hive metastore, and the Hive metastore has like some complicated APIs, and there's just a whole lot of like weirdness around just like the Hive data model because it just evolved over time. And so, and another issue is that you have both like the metadata in the metastore, and you have the data on disk on the distributed file system. And in like cloud object stores, like listing files is really expensive. And historically, S3 had problems where it was eventually consistent. So you might write some data, and then somebody goes to read it and they miss it. We're really excited that S3 recently announced not eventual consistency for everything. I can't remember the right term, strong consistency. So Iceberg solves this by you basically get rid of the Hive metastore, and now you store all your metadata in metadata files on disk. And those metadata files are immutable. So you write data, you write the metadata file, and then you just have a pointer that says, this is the current version of the metadata file for my table. And it allows you to do ACID transactions, because you just, if you want to do like an insert or a delete operation, you write some new files, and then you write a new metadata file describing the changes, and then you update the pointer to point at the new metadata file.
Ah, okay, yeah.
So it's actually a lot simpler than the Hive model, because it's just files. It's a lot more flexible. It performs better. It's got a much better partitioning model than Hive, because it's about transformation functions. So whereas Hive has like partitioning and bucketing as like separate concepts that don't really interact, in Iceberg, it's actually just, well, value-based partitioning is just an identity function. Bucketing is a hash function. And then you've got other functions like I can take a date, and I can truncate, or I can take a timestamp, I can truncate it to a date, I can truncate it to an hour, and you can just combine all of these on different columns in your table. And Iceberg also lets you do evolution, where you don't have to have consistent partitioning across the entire table. So like maybe I was bucketing by date, and now I'm getting a lot more data, and I need to start partitioning it by hour. Well, you can just change the partitioning, and all your new data is partitioned by hour, and it's all just transparent, because that kind of evolution has always been a problem with Hive.
I would say the thing I am actually most excited about it is Iceberg has a spec. You want to know how something works? You go look up the spec. And there's a community, and the community is focused on, how do I map data to these files? How do I collect metadata about them? And that's the entire job of the community. The community isn't like, oh, and by the way, we're writing an entire distributed query engine. And so like they have the focus, and it's really easy to follow. And then like you can go and like talk to people about these. There's someone to actually talk to about like spec level things. So, you know, as we started to dig into this, like, well, how do we want to represent statistics? What if we needed our own statistics for Presto that were custom to Presto? How would we do that? Is that something that we want to do at Iceberg? And like there's a whole community there that all they're thinking about is like, how do we organize data? How do we solve these really hard problems? And there are a lot of problems for a bunch of companies involved in it. I'm really excited. Like, I think it's a great team, really excellent community, super exciting.
Any closing thoughts on this?
Well, one thing I want to mention is that Trino already supports Iceberg. There's a plugin. It's not something that's coming up. It's already there. It's being used by companies like Netflix, LinkedIn, and of course there are a bunch of companies investing in Iceberg itself. I think Apple is also investing in it. So I think it's going to become popular, and hopefully will become one of the storage layers of choice for Trino.
Maybe in contrast to traditional specs like Iceberg, all the people working on it and working on the spec are people that are using it, and they're involved because they want to solve their real problems, not just like a committee that decided, oh, maybe we'll invent this data format and maybe it'll be useful. Like these are all people that had a real problem to solve.
Stakeholders, yeah.
I would like to maybe take a step back and talk about the bigger context of what we've been talking about in this conversation. Backing up, like, you know, we're talking about data science, and like it's a really hard problem. Data silos, there's lots of people, there's politics, there's security laws. Like, this is a really big, complex subject. And like my general summary is like, there are no silver bullets out there. Like, I think the way we did it, the way we approach it in Trino, I think this helps a lot, and it moves the problem forward, and really can help make, you know, the lives of people better. And I'm sure there's more we can do. And if, you know, anyone on this is working on it and wants to see more out of it, like, come join us in the community. Like, ideas and like actually good problems are what really drive the community. Like, a lot of the features we have, like Iceberg's an example of like people with really good problems coming together. Trino's a lot like that. Like, big complex problems coming together. Like, how do we make a system that works for kind of everyone and solves everyone's problems, with a goal of we're going to make things better, not we're going to solve the world's problems.
Well, what's the best place for people who want to get involved, who want to reach out to the community?
Our website, Trino.io. If you go there, what you want to do is you want to join Slack. There's a ginormous Slack community. It's worldwide, global. There are, how many people are in it now, Martin?
3,500 or so.
Yeah. And there are people talking about stuff, helping each other out, development, interesting problems, etc. It's a really big and nice, really awesome community. Super happy.
I mean, data engineering is hard. It's not just a matter of making sure that a query runs. I wanted to dig into this more because I think that this topic probably deserves a lot of discussion. And David, I'll toss this over to you. Let's dig into this a bit more about understanding what needs to be done in the scope of data engineering, and also just how does Trino help to improve this?
Yeah, so there's a lot of challenges. Like, you need to know what the columns in a table mean. Like, you might have a user ID column and they just named it differently across a bunch of different tables. And then you also have to understand semantically what your data means. Like, you might have a table that's logging information about visits to the website, but then what does a visit mean? Like, is that a user hitting a single page? If they hit multiple pages, are those multiple visits? Is this like one user visiting the site over the course of an hour or a day? And just to be able to ask that question, you have to actually understand what that question means, and then you have to understand how the data is representing that. And sometimes those things align, sometimes they don't. And you might talk to 5 people and get 5 different answers about what they think it is. There's challenges around how you're capturing information from like your applications in the company, and there's trade-offs. That you can have a centralized team that has to make sure that everything is standardized. That's going into your warehouse, but then that means that there's a bottleneck. And if someone wants to like log some more data, then they've got to talk to this team and wait. Alternatively, you can just have everybody log the stuff directly, and you might not even add a column to a table. You might just, I have a JSON blob and I just add more columns to my JSON blob. And like, well, that's good from the standpoint that now the developers can move fast, they can be constantly adding and changing things, but now that's shifting the burden to the people that are trying to analyze that data, because now it's like, okay, I got this JSON blob, like, what are the columns in here? What does it mean? Like, oh, the schema of it is different from this week to last week because they changed the application. I've got a bunch of different versions of the application, running on like mobile devices, and they're all logging different types of data. And so the good thing about Trino is that you can actually query this data and you can solve these problems, but the people who are having to write the queries now have a really difficult job. So you can either do more work up front to make their jobs easier, or you can have them do more work, but let teams move faster. And it's really a balance in the business.
Yeah, so I mean, there's work, there's overhead here, and people can sort of kick the can down the road and just ignore it for a while, but then you're incurring tech debt. I mean, very formally. For what it's worth, there's been some academic study about this now too. Professor Joe Hellerstein at Berkeley has been leading some work in this area. They're calling it, well, there was a project called Ground Context, but they're calling it data context as from an academic perspective. I mean, this is recognized as just such a pervasive problem. Well, I want to thank you all very much, Dain, David, Martin. Really enjoyed the conversation today, and also I'm just super impressed with the work that's going on at Trino. Thank you very much.
I hope that was a helpful deep dive on Trino, and it helped you understand how using Trino for ad hoc exploratory analytics can really unlock more data for data scientists to use without needing to wait for the data to move or be prepared. Now I'm standing in your way of a break, so go ahead and take one, and we'll see you back here in 15 minutes for what might be my favorite talk of the entire 2-day event, the data literacy imperative. See you in 15.